Kia ora Year 12, this video is going to go over how to use the method of completing the square to solve equations. If you'd like to have a go at these first, just pause the video now and just work through as far as you can. I'm going to go through each equation on a separate slide. Okay, so here's the first one, x squared plus 8x equals 20. There are a couple of different ways to solve these problems. The method I'm going to use is to get everything over to one side of the equation and have it equaling 0. So I'm going to start off by subtracting 20 from each side. So x squared plus 8x minus 20 equals 0. Now when I use completing the square, I focus on the first two terms. I think about how I'm going to get a square from the coefficient next to the x of 8. So I'm going to halve that number. So I'm going to have x plus 4 all squared minus 20. And now I need to make a little adjustment, because by putting in x plus 4 squared, I have added in an extra 16 to the left hand side of the equation, because the 4 times 4 gives me an extra 16. Okay, so if I expand out that squared expression, x squared plus 8x plus 16, this is the extra bit. So I need to subtract that off. Okay, so I've added it in there, and I've taken it out there, so I haven't changed anything. So now what I've got is x plus 4 squared minus 36 is equal to 0. So x plus 4 squared equals 36. Okay, let's do a little bit more working up here. Now we get this, x plus 4 is equal to plus or minus the square root of 36. Okay, so far so good. I've taken the square root of both sides. So the last step is to solve it for x. X is equal to negative 4 plus or minus root 36. Now the square root of 36 is just 6, so I get x is equal to negative 4 plus 6, or x is equal to negative 4 minus 6. So the final answer, x is equal to 2 or negative 10. Now in this case we could have done that example pretty easily by simply factorising in this equation here. Okay, but there'll be times when completing the square turns out to be a useful method, so that's why I've started out with one that you could do either way. Okay, x squared minus 6x plus 2 is equal to 0. So again, I focus on the first two terms, and I halve the negative 6. I get x minus 3 squared plus 2. Now I've added in negative 3 squared, which is 9, so I need to take it out. So it's plus 2 minus 9 equals 0. If you're not sure about that step there, just off to the side of the page, expand that out and see what you get. And you will have an extra plus 9 term coming in here, x squared minus 6x plus 9. So that's the add-in factor. We need to take it out to keep it balanced. So now I've got x minus 3 squared equals 7. I get x minus 3 equals positive or negative square root of 7. So x is equal to 3 plus root 7, or x is equal to 3 minus root 7. Okay, and it's fine to leave your answer in that form. Next one. A little bit harder now, because what I've got in here is a coefficient of 2 for the x squared, but the method stays the same. I'll just switch back to a black pen. So we have 2x squared minus 10x minus 3 equals 0. So we put a little box around here, but we're going to do an extra step first. We're going to take out the common factor of the 2. 2x squared minus 5x minus 3 equals 0. Now we look at this part here. Right, we're going to have a few fractions popping up in here. Never mind. So we still do our method of halving that term, and we get x minus 5 over 2 squared minus 3. Now I have to look closely at what our add-in factor is here. Well, over here we have 2 times x squared minus 5x plus 25 over 4. So you can see that the add factor is 2 times 25 over 4. So I need to take that out, so that's minus 50 over 4 equals 0. So now I've got 2 into x minus 5 over 2 squared minus, I'm going to do this slowly, I know lots of you don't like fractions, so minus 3 minus 50. I'm going to multiply the 3 by 4 to get 12. 12 plus 50. Don't worry, I am going to simplify this fraction here, in case you're getting nervous that I've forgotten. So we've got 2 into x minus 5 over 2 squared is equal to 62 over 2. Right, can't stand that. Oops, 62 over 4, can't stand it any longer. That's going to be 31 over 2. Need to have a new slide now. Right, so we're up to this 2 into x minus 5 over 2 squared is equal to 31 over 2. Right, now this term here is the new bit. I need to divide the other side through by that. I get x minus 5 over 2 squared is equal to 31 over 4. So x minus 5 over 2, taking roots of both sides, is equal to plus or minus root 31 over 4. X is equal to 5 over 2 plus or minus, now a bit of simplifying here, 31 divided by 2. Right, nice way to write that is x is equal to 5 plus root 31 over 2, or 5 minus root 31 over 2. Okay, just a little bit more practice here with one where the coefficient is not 1. I'm going to rearrange that to have 3y squared minus y minus 1. Just notice that, as usual when we're doing quadratics, I have tried to keep things in the same pattern. So the y squared term, the y term, and the constant term, and that equals 0. So 3y squared minus y, that's what I'm looking to complete the square with, take away 1 is 0. 3 into y squared minus 1/3 y minus 1 equals 0. So as usual we're going to halve that term, y minus 1/6 squared. Might as well put that one back on the other side now. There's the 1. Now let's take a look at what our add-on factor was here. If we expand that out, we'd have 3 into y squared minus 1/3 y plus 1/36. So we have added in a factor of 3/36 or 1/12. So we need to get rid of that. So it's going to be, now I'm just going to erase something. Sorry about this. People in my class will be used to it. I'm going to leave things in the pattern I've been doing right through till now. I'm not going to take that 1 over yet. Okay, so we'll keep it like that. So what we've got to have in here is we have to take out the added in factor. So it's 3 minus 1, 3 times this bit here, take away 1, but now I also need to take out the 1/12. Right. So we get 3 into y minus 1/6 squared equals 13 over 12. move up here now. Next step is to divide both sides through by 3. So we get y minus 1/6 squared equals 13 over 36. Y is equal to 1/6 plus or minus the square root of 13 over 36, which equals 1 plus or minus the square root of 13 over 6. Right, we have a common factor popping up in here. The square root of 36 is 6, and this is 6. Okay, so final answer there is those two values of y. Y is equal to 1 plus root 13 over 6, or 1 minus root 13 on 6. Oops, extra slide. There we go. Okay, so 5k squared plus 3kx minus x squared equals 0. First thing to notice in here is that this is in backwards order. So we're going to times it through by -1. X squared minus 3kx minus 5k squared equals 0. There's no big difference here. It's just that our coefficient has got a k in it. So to complete the square, we're going to have x minus 3k on 2 squared minus 5k squared, and we have added in this term squared, so we're going to take it out. So minus 9k squared on 4 equals 0. Now we've got x minus 3k divided by 2 squared is equal to 5k squared plus 9k squared on 4, which is equal to 29k squared on 4. Now, this gives me, if I take square roots of both sides, x minus 3k on 2 is equal to positive or negative square root of this. So x is equal to 3k on 2 plus or minus the square root of 29k divided by 2. Right, final answer up here. Just put a wee line down there. X is equal to 3k plus root 29k divided by 2, or x equals 3k minus root 29k divided by 2. But there's a slightly nicer way that I can write that, so I'm going to take an extra slide to do that now. So we've got x is equal to 3k minus root 29k on 2. We're going to simplify that by taking out the k.
Stop the recording!
Okay, so 3 minus root 29k on 2, or 3 plus root 29k on 2. Okay, if that's freaking you out a little bit, I wouldn't stress too much about it. That's very likely to be excellence level only at level 2. However, it is a really useful bit of algebra practice, and it can come in handy in some strange places. Thanks for listening. I know this was pretty long, so well done for getting to the end, and as usual, let me know if there's anything you want me to change.